Good day. I am John Barriga from BSIE Day, and today I will discuss about line balancing. So let's get started. Before we proceed to the main discussion, let us know first about line balancing. So line balancing in a layout means arrangement of machine capacity to secure relatively uniform flow at capacity operation. It is also the process of assigning tasks to workstations in such a way that the workstations have approximately equal time requirements. So it can be also said as a layout which has an equal operating times at the successive operations in the process as a whole. In line balancing, there also has an objective which has 5, namely, number 1 is to manage the workloads among assemblers. Number 2, recognize the location of bottleneck. Number 3, decide number of workstation. Number 4 is to decrease production cost. And lastly, number 5, assigning tasks to each workstation in such a way that there is little idle time. So the main objective of line balancing is to equalize the workloads among the operators. It also includes the reduction of the production cost and to determine the labor cost of production and to establish the percentage workload of each operator. So in our next slide, we have the line balancing process. So we have steps in solving the line balancing. First, we have to draw and label a precedence diagram. So the precedence diagram needs to be drawn to demonstrate a relationship between workstations. Certain process begins when previous process was done. Second is to calculate the desired cycle time for the line. So cycle time is the time expressed in minutes between two simultaneous products coming off the end of the production line. So third is to calculate the theoretical minimum number of workstations. Fourth is to group the elements into workstations, recognizing cycle time and precedence constraints. And to calculate the efficiency of the line, which has to calculate the effectiveness of the line. And lastly is to stop if the theoretical number of workstations on an acceptable efficiency level is reached. If not, let's go back to step 4 until we reach our target. So here we have an example, a table composed of task, precedence, and duration. So we have 9 tasks and each task has a precedence and its duration and has an output of 13 units and 200 minutes available time. So task A has no precedence and a duration of 10 minutes. Task B has a precedence of A and a duration of 11 minutes. C has a precedence of B and a duration of 5. D has a precedence of B and a duration of 4. E has a precedence of A and a duration of 12 minutes. F has a precedence of C and D and a duration of 3 minutes. Task G has a precedence of F and a duration of 7 minutes. Task H has a precedence of E and a duration of 11. And lastly, task I has a precedence of J and H and a duration of 3 minutes. So I have already drawn a precedence diagram to speed up a little bit of our discussion. To come up with this kind of diagram, you must identify the precedence of each task based on our table before. So we have task A with the precedence of B and E. B to C and D, C and D to F, F to G, G to I, E to H, and H to I. So we are done to our first step is to draw the precedence diagram. Our next step is to calculate the desired cycle time required for the line. So the formula used in calculating the cycle time is CD is equals to available time over output. So we have 200 minutes available time, which is to substitute this formula, and the output is 13. So 200 divided by 13 is equals to 15.38 minutes per unit. So our cycle time is equals to 15.38 minutes per unit. And our next step is to calculate the theoretical minimum number of workstations. So the formula used in calculating the workstations is N is equals to the summation of standard time over CD, which is the cycle time. So standard time is the total time of the durations. So input all the numbers to the formula. So the summation of standard time is 66 and a cycle time of 15.38. So 66 divided by 15.38 is equals to 4.29, and it approximately has 5 stations. So our theoretical number of workstations is 5. And now we have to calculate the efficiency, which has a formula of summation of ST over N times CD. So our N is the total number of tasks, which has 9, and input all the numbers into the formula, which has ST has a 66 over 9 times 15.38, and we have come up with a final answer of 47.7%. So our efficiency is pretty low, and to increase the rate of this efficiency, we have to group the elements into workstations. So before we proceed in grouping the elements, we have to identify first the followers of each task. So we have a precedence diagram before, and to identify each followers, we have to base on this diagram. So here is the table. I have already input the followers, and to identify, task A has 8 followers. So identify the followers. The followers of A has 8. It has B, C, D, E, F, J, H, and I. So it has 8 followers. So task B has a 5. So the followers of B is task C, D, F, J, and I. So task C has only 3 followers. So C has 3 followers. Task F, J, and I. Task D has 3 followers. F, J, and I. C and D has the same followers. So task E has 2 followers, only H and I. Task F has only 2 followers, the same with E, J, and I. And last is task H, which only has 1 follower, which is I, and I has no follower since it is the last task. I almost forgot, the task G has also 1 follower, which is I. To proceed to our next step, we have to identify how many tasks should be placed or put into the workstations. And from what I said earlier, the theoretical number of workstations is 5, and to prove this answer, we must group each task depending on its duration in each stations. So I have already presented a complete information, and to further discuss, to identify of how many tasks should be assigned, we should minus the cycle time, which is the 15.38, to each of the duration of each task. So task A is assigned in station 1 because it has a remaining value of 5.38, which is 15.38 minus 10, the duration of task A. We can get from the table before is equals to 5.38. Station 1 has only one task assigned because there are no other tasks that can be subtracted from the remaining time that has a precedence of task A, and task B and E can't be used since it has a higher value of duration. So station 2 has two assigned tasks, task B and D. So 15.38 minus the duration of task B, which is 11, is equals to 5.38. And B has a precedence of D, so task D can be also assigned in this station. So the remaining value is 4.38 minus the duration of D, which is 4, is equals to 0.38. And in station 3, we have also two tasks assigned, which is task E and F. So the cycle time, which is 15.38 minus the duration of task E, is 12, is equals to 3.38. And task F has a duration of 3, so task F can be also used to subtract from the remaining value. So 3.38 minus 3 is equals to 0.38. Task B has already assigned, and task C is the precedence of task B, so task C can now be assigned in another station. So 15.38 minus 5, which is the duration of task C, is equals to 10.38. And 10.38 can be subtracted from the duration of task G, which is 7. So task G can also be assigned together with task C. So 10.38 minus 7 is equals to 3.38. And now we have two remaining tasks. Let's see if these two should be assigned in this last station. So task H has a duration of 11. So 15.38 minus 11 is equals to 4.38. And task I has a duration of 3, which can also be used to subtract from the remaining value. So 4.38 minus 3 is equals to 1.38. And now we have assigned all the tasks into 5 different stations, and this proved that the theoretical number of workstations we have calculated earlier, which is 5, is correct. Down to our last step is identifying the balance side and the new rate of efficiency and the effective output. Now we have grouped the tasks into their stations. Station 1 has task A, Station 2 has task B and D, Station 3 has task E and F, Station 4 has task C and G, and lastly task H and I in the Station 5. So this is the balance side of our problem. These numbers below the stations is the total durations of the tasks assigned in each stations. So task A has 10, and task B, which has a duration of 11, and D has 4, and a total of 15. Task E has 12, and F has 3, a total of 15. Task C has 5, and G has 7, a total of 12. And lastly, task H has 11, and task I has 3, a total of 14. To calculate the new efficiency, we can change the value of n from the formula, which is 5, and 5 is the number of workstations. Input all the value into the formula. 66 divided by 5 times cycle time, which is 15.38, is equals to 86%, which has a big difference compared to our last answer, which is the 47.7%. To compute the effective output, we have the formula available time over the effective cycle time. Input all the value and we'll come up into 200 divided by 15.38 is equals to 13 units, which is correct from our problem. And that's all for my report. Thank you and God bless.